Thank you. I really like your background.
Thank you.
I'll also go ahead and make you co-host.
Yeah, Lynn said she was waiting, so she should be here shortly.
Cool. Yeah, I think I just I turned off waiting room, so it shouldn't be. How was your day so far?
Good. I sat in on the wildfire, so that was interesting. Yeah, Vince did a nice job.
Yeah, that was a very interesting workshop.
Yeah, we've been working with him for a few years on this topic.
Yeah, I thought it would be kind of cool to, bring into the challenge, because you guys are the ones that can hack and really bring all the data that we need to get. And, I think that it's a way to develop some cool apps and connect. And then the orbital debris will be interesting way to kind of tie everything together too. Because Bruce and Dan and Lisa and Vince and myself kind of work on the wildfire task. And then so to see how the space industry has all these different things that can offer challenges here on Earth and solutions that we have. So we're asking you to come up with some ideas.
There's Lynn.
Hello. Good morning.
Good morning.
Hi. I'm good. How are you?
I'm doing pretty well. Woke up pretty early. It's nice.
You ready to start?
Cool. I'm ready to start whenever you are.
Okay. I thought what we start off with was a little bit of background, because I think that's helpful for both Lynn and myself. So let me start, and then Lynn can kind of fill in your background, because I think they're both interesting and illustrative. I have been interested in space ever since I was a little boy. Actually, kind of aging myself, but John Glenn went into orbit on my 10th birthday. And so I kind of thought that whole thing was for me. And everything was kind of a great birthday present. And so when I went to college, I decided to be an aerospace engineer, even though I wasn't quite sure what an aerospace engineer was. And so about my third year in college, I thought, well, maybe I ought to find out if this is really what I think it is. So I was trying to find a way to get an interview. I didn't really want a job. I wanted an interview. So I was at UC Davis in California, and I came across a program called Cooperative Education, co-op program. And so, and again, this was one of the things that I've always advised people: read bulletin board. So if I hadn't read the bulletin board, I wouldn't have found this. So be inquisitive and look around. So I filled out all these forms for all these things, with the Navy and with Lockheed and everything. And one of them was with NASA. And so I waited a couple of weeks and I didn't hear anything. And so, but then right before Christmas, they gave me a call and they said, hey, we'd like to talk to you. So I got in my little Volkswagen and drove from Davis. It's about 2 hours from Davis to NASA Ames. And so I drove over there, and sure enough, they wanted to give me a job. And I thought, this is even better than an interview. And so I took the job, which was really an amazing experience. So, my number one recommendation here is when you get an opportunity, take it. Even though I didn't know anything about what I was going to be doing or whatever, it was a great learning experience. Worked with an amazing group of people. It just, again, not only the NASA community, but we had a lot of what are called postdoctoral fellows from all over the world. So I worked with people from Japan, people from Germany, and all over the world while I was there. And I got a chance to actually do some research. So that was really cool. And then after I graduated, I got to work on planetary missions. I was one of the implant reps on a mission to Venus called Pine Venus back in the late 70s. So I was one of the last people to touch the spacecraft before it launched. on the morning of the launch. So that was a really cool experience. You know, like I was, I think at the time I was 26 years old. And so I'm getting to launch a spacecraft to another planet. And it worked really well. It was supposed to last for 1 Venus year, which is 243 days. It actually ended up lasting for 13 years. So that was a pretty cool experience. After that, I went to infrared astronomy, so another really kind of heavy techie kind of thing. So that would be my other suggestion here is you may not always have exactly the credentials that you need, but if somebody offers you the opportunity and you like the steep part of the learning curve, I would recommend that you take it. So that has served me well, but you got to like that steep part of the learning curve where, you know, you're just kind of tossed into the swimming pool and you got to figure out, you know, how to swim kind of on your own. But that always appealed to me. And then in the mid 80s, I left NASA. I got the entrepreneurial bug. So I left NASA and went out into the world. I became a management consultant. I helped start a couple of companies. One of them was a space company called SpaceHab. We actually built and flew modules in the space station thing. And Lynn can talk about that because she actually utilized the SpaceHab module. I was only with SpaceHab for a few years, but it was a great learning experience, again, about how to get something off the ground. We went on and got a contract with NASA, was able to go and build several of these modules and fly them on the space shuttle. So did a lot of that kind of work. And then about 15 years ago, I got a chance to come back to NASA because I found out I really missed space. And so I've been working with the Space Portal, and now I'm working through a company called SkyCorp, and we have a new technology, a new way of making satellites where instead of assembling them and testing them on the ground, we assemble and test them on orbit. So we're going to fly our first test component here to the space station in the end of this year, and then our full satellite is supposed to go up at the end of 2023. So we're really excited about that. And so obviously anybody that's in the satellite business is worried about orbital debris. And so that's why we decided to put up this challenge. And so let me have Lynn introduce herself, and then I'll show you a short video clip that I found online that kind of gives some really nice background information about what the challenge. And then we'll go through some of the different elements that you might want to think about as far as your challenge goes. So Lynn?
So my name is Lynn Harper. I'm lead for integrative studies for the Space Portal at NASA Ames Research Center, and I work with Bruce and Hab every day since 2005, and it's been a terrific experience. I didn't know Bruce when we started, but I used the SpaceHab facility that he talked about on on the space shuttle, and it.
Did she cut out for me?
To my father. Excuse me?
I'm sorry, I think you cut out, or was that just me?
No, I'm so sorry. So what you may find, can you hear me now?
Yeah, you might want to turn off your video, Lynn. It looks like
I'm gonna have to. Yeah, this happens to me a lot, and especially when I run with video. So I'm going to turn the video off. Okay. So just to let you know, I got interested. I'm a fireman's kid from Bridgeport, Connecticut, and that was pretty far away from the nation's space program, to be honest with you, during the 1950s. And one night, my dad got me out of bed in the middle of the night and said, "Let's go outside." It was cold, and I had to bundle up. And we went to the end of the driveway, and we lived in a place with dark sky at that time. And he said, "Look over there, do you see that star move across the horizon?" And I did see it. And I said, "What is that?" And he said, "That's the world changing." So later on, I would find out that that moving star was called Sputnik, and it was the first orbital spaceship. And the second thing was that my father was right, that was the world changing. After that, we were always interested, I was always interested in science. I love to know how things work. And I was interested in all of the science, which for integrative studies is a good thing to do. But I actually got into NASA through the Boy Scouts. When I was in my late 20s, a remarkable man by the name of Fred Wolf bought 5 cubic feet of space on the space shuttle and donated it to the Boy Scouts to develop an experiment for space. And at that time, I was a floor executive for science and business for the Boy Scouts of America. Well, make a long story short, that gave hands-on experience and gave all of us hands-on experience in developing payload for space. And I was hired as a contractor to NASA in 1982, and then was hired by NASA in 1986. And since then, I've been instrumental in the development of over 100 investigations space. 5 of which are active right now in development for the space station, and other 5 are under development by my colleague Dan Rasky as technical monitor. So I guess to sum up where I am on all of this and what I would like to leave all of you with is you're going to spend best hours of the best days of the best years of your life at work. So it's worth whatever education and training you need to get something that you love. And I can tell you, I've worked with NASA now since 1978, and I love my job. Most fun I ever had on it was last month, 2 months ago actually, during December, when we were running a set of the first manufacturing experiments for optical fiber. And the problem real time, and we're troubleshooting real time, and it worked. It was terrifically exciting. It's probably the most interactive I've ever been with a spacecraft. So where we get what I do for a living is basically investigate areas that are either undervalued and should be supported, or are ready to go into an implementation, but there's nobody that's a receptor site. And so what I do in integrative studies kind of fill in the blanks to make things work and get into flight. And that's how I crossed paths with Orbital Debris. It was investigating something that dealt with the following question. For every kilogram of mass you launch into space, can you get 5 kilograms of value back from it? And so that, oddly enough, took us to orbital debris, but we can talk about that part later. I'll turn back over to Bruce. Bruce?
Thank you, Lynn. Sorry, I had a little reboot problem here, so let me get myself recombobulated here. So let me try to show you this this video. So if I can try to do this and see if the gods are with me here.
Streaming service that offers over 2,000 documentaries, including exclusive originals from some of the world's best film.
Whoops, let me go back.
Yeah, the screen isn't showing, Bruce.
Yeah, I got to do the sharing part.
Explorations to outer space, a new problem has emerged.
I think I allowed sharing for all attendees, so that should be fine.
So let me do the screen share. And then
numerous, hard to track, and dangerous are the central reasons why space debris is a threat to both the safety of our astronauts and the safety of our assets in space. But what most people don't know is that we do have a structured solution for all of this. It involves what I call a 3-step process: prevention by design, capture, and finally removal. So without any delay, let's talk about it today. Over the past decades, space debris problem has become a headache to space operators. Depending on the size of the debris, at any point in time, there are over 17,000 baseball-sized space junk floating around in space. Floating is probably not the right word to use because every one of them is traveling at over 20 times the speed of bullets. Estimated by the European Space Agency, there are over 29,000 objects with a size greater than 10 centimeters flying around in space. 750,000 objects between 1 to 10 centimeters, and over 166 million objects that have a size between 1 millimeter and 1 centimeter. Infinite as a universe, the Earth's immediate space is quite a crowded zone. Not only that, it's also a dangerous zone because of the speed of those debris. As I mentioned, it's at least 20 times the speed of a bullet. Therefore, even the smallest debris could cause a disaster in space. To add to this, Kessler syndrome also dictates that the danger of space debris could be accelerated by collisions among them, which will cause a chain reaction that results in a totally uninhabited Earth orbit. It will become a death trap for future missions if we don't stop it. In the same paper, Dr. Kessler further concludes, the processes which will produce these fragments are totally analogous to the processes that probably occurred in the formation of the asteroid belt, required a much shorter time. Dr. Kessler calls this a debris belt, and if it became a reality in the future, no space missions would be possible. This is how dangerous space debris is. Lucky for us, after he explained the danger of space debris in the 1970s, NASA took it seriously and started researching on how to remove space debris. Good call, NASA. Good call. That's part of the reason why most satellites now have a deorbit instrument that pushes the satellite back to Earth when it's no longer in service. Launch providers also actively deorbit its abandoned stages to fall back to Earth so they won't contribute to space debris. But before I explain further, you might be wondering, why is this video titled NASA's Space Debris Problem? Doesn't space belong to all of us? How is this a NASA problem? Here's the thing. As much as we romanticize space exploration, countries are not created equal in terms of our space resources. The United States has a much larger stake in space than any other countries in the world. For example, NASA paid for half of the $100 billion International Space Station, a portion that's larger than all the other countries combined. Most satellite producers, launch providers, as well as launch support facilities are based in the United States. In terms of the satellite business, over 60% of satellites in space are either serviced by American companies or are direct assets of the American government or American-based privately owned enterprises. So it is not at all a stretch of imagination to claim that the space debris is an American problem because America has benefited most from the space. From a capitalistic point of view, Americans own more properties in space than any other countries in the world by a large margin. Obviously, NASA knows about this. It started researching on space debris removal since the 1970s, and lucky for NASA, it is not easy for a piece of space debris to stay in space forever, especially for lower Earth orbit missions. In fact, most objects that has ever reached space came back due to gravity. In order to truly stay in space forever and escape the Earth's gravitational influence, an object needs to achieve escape velocity, which is 11 kilometers per second. So it would be too hard for us to accelerate space debris to that velocity. But lucky for us, space debris do not need to achieve that velocity to be harmless. This gets us to our first way to mitigate space debris, prevention by design. Specified by the United States government Orbital Debris Mitigation Standard and Practices, a used satellite is required to do one of the following three things if possible: atmospheric re-entry, maneuvering to a storage orbit, or direct retrieval. Storage orbits are commonly referred to as graveyard orbits because all used satellites and abandoned rocket stages go there. 4 potential graveyard orbits are being used currently. Each is used for satellites in different orbits: low Earth orbit, medium Earth orbit, geostationary Earth orbit, and beyond. If you're interested in the details, check it out in the link down below. The first two methods are frequently done. SpaceX fans should be familiar with this because used falconized stages deorbit all the time. But if none of the prevention measures are made, direct retrieval is necessary. Many companies are working on it, and all of them involve a two-step process: capture and remove. In a paper published in 2016, Sean outlined the various methods of capturing and removing space debris. Capturing debris, we can either use a contact method or a contactless method. And as you can see, they're self-explanatory. Some captured by nets, some captured by robotic arms, so I won't explain further. When it comes to removing debris, however, some methods do not even involve capturing at all. The laser system is a good example. It uses pulsed laser beam to shoot onto a space debris to decrease its altitude. Other contactless method includes artificial atmosphere influence and ion beam. Regardless, The general principle of all this method is to decrease the velocity of space debris, thus lowering their altitude by ejecting some medium objects in their trajectory. Depending on the particular characteristics of the debris, different capturing and removal methods should be used. This is the harder part of solving the space debris problem. However, the good news is that just in the last few years, private startups and companies have entered this field, including SpaceX. The biggest challenge for them, in my opinion, is to make the removal method adaptable to different types of debris so that their services could be adopted by most companies in the world. You know what? Adapting to it is what startups are all about. If anyone in the world can solve the space debris problem, I would bet on private startups, just like how startups solve the reusability problem in the launch market. Lastly, although we've been talking about limits to Earth orbit, if you're interested in the Moon, Mars, or beyond, check out Curiosity Stream, sponsored.
Okay, so that kind of gives you the basic background about orbital debris. There's a lot of it out there. We also had a, I don't know if it got up on the website, but we had a kind of infomercial kind of a thing that talked about some of the highlights of orbital debris. I think that's available online as well as background. But let me go into a little more detail here because it is a complicated issue here. So let me dispel a little misinformation. How many of you saw the movie Gravity with Sandra Bullock? I mean, the video, the graphics in there were beautiful, but obviously whoever wrote that and made that, understands nothing about orbital mechanics. The fact that, it doesn't work that way. No. You would never even see a piece of orbital debris coming at you at 17,000 miles an hour. So it's that was just a little bit. Now you give them some artistic license, but one of the challenges of orbital debris is this thing called orbital mechanics. To put something into space, you have to add a great deal of energy to it. That's you get. To go into orbit, you have to reach a minimum velocity of 17,500 miles an hour. The 11 kilometers a second, that translates into almost 25,000 miles an hour is escape velocity. That's also the velocity you need to get to go to the moon. So those are some of the basics. What's interesting is that you launch, when you launch into orbit, you go into a particular orbit at a particular inclination to the equator. So if it's along the equator, that's called equatorial orbit and things like that. If you go over the poles, that's called polar orbit. But there's all the orbits in between all 360 or 180 degrees of the compass, you could have an orbit. To change your orbital inclination requires energy. So here's an interesting thing to keep in mind. To go from an equatorial orbit to a polar orbit to do what's called a plane change, that takes about the same amount of energy as it took you to get to orbit in the first place, almost 8 kilometers a second. So it requires a great deal of energy. So that's one of the things that makes, since all this orbital debris that you want to get rid of is not in one orbit, then that makes it difficult. So you have to figure out what the orbit of the thing that you want to deal with is, and then you need to get to it. So that's one of the challenges. Now, the good news here is some of our friends have done a lot of work on this. One of our colleagues that Lynn and I have worked with over the years is a guy named Joe Carroll. And Joe Carroll is very interested in this topic. He worked with some other folks at Able Engineering, and they came up with some really neat ideas for this. One of the ideas they came up with, which you might want to look at, is a thing called an electrodynamic tether. And what this does is actually uses electricity to produce where if you run a current through a conductor, it creates a magnetic field. And that magnetic field that's close to the Earth can react with the Earth's magnetic field. So they were able to come up with a concept for a vehicle that would have what's called an infinite specific impulse, because it didn't use any fuel, because it was using electricity, which you got from solar panels from the sun and the Earth's magnetic field to do this. So that's one of the things you might want to go look at. But the other nice thing here is that what you really want to get rid of is a few of the really big items up there in space. Some of these, some of the videos I watched, they were talking about the proliferation of CubeSats and everything. I don't see that as a big problem. There's some really big hunks of used rockets and satellites that are dead, that are spinning around up there. And those are the things that are going to make this work if any of those two things run together. And this happened back in 2009 when a dead Russian satellite ran into an active Iridium satellite and created a massive plume of orbital debris. And so that's what the Kessler syndrome is all about, is when two objects that are relatively large run into each other, and then they create a whole raft of other debris out there, and then that debris creates more debris, and that's kind of what the Kessler syndrome is all about. And the final thing I wanted to talk about was the legal issue here. If you're in the working on the ocean and a ship breaks down or a ship sinks or something like that, there's what's called the right of salvage. That once that ship is abandoned, somebody can go and salvage that and make sure that it's not a hazard anymore. Space isn't that way, and I'm gonna give you some information in just a second on how this works about that if you launch something into space because of the Outer Space Treaty, which was in 1967, that if you launch something into space, you own it forever. And if somebody goes up and touches it and deorbits it, that's actually considered to be you're stealing it. And so there's all kinds of legal and liability kinds of considerations that goes along with that. So there are issues in the legal and regulatory realm that also have to be dealt with if we want to deal with that kind of a thing. And then the final thing, though, is up till now we've been talking about this as a hazard, as a threat. And it also, you've got all this high quality metal and materials up there. So, I'd like Lynn to basically talk about what some of the benefits of this might be if you could recycle this material. So Lynn, are you still with us?
I surely am. Can you put up the slide deck that I sent, or is that something maybe that I can share here? We could try it.
Yeah, I can go look for it, but I don't have it right here.
So can you see it?
Yeah.
Oh, good. Okay. All right. Now, do I need to make it full screen? Because I actually can't see what you're seeing. To me, I can't see it all on the screen.
Fine. It looks fine.
Okay. Okay. So what this is a study. So you take the orbital debris and you go, that's a lot of orbital debris and it's getting worse all of the time. But one of the best pieces of advice that I've ever gotten, technically and in life, is don't just use things for what they were designed to do, use them for what they can do. And anybody that's ever used a butter knife as a screwdriver understands the basic principle. So what if we don't look at the orbital debris as a problem? What if we look at it as an asset? Now what can we do? So in 2016, under the Office of Chief Technologist, an idea from the White House, from Tom Khalil, who was in the Office of Science and Technology Policy under President Obama, gave a challenge to NASA, which says, for every kilogram of mass launched to space, can you repurpose and reuse launch assets to obtain 5 kilograms of value? So what do we got to work with? We have a lot of debris. That's a lot of mass in microgravity. It's a lot of aluminum, titanium, magnesium, steel, nickel alloys, carbon, niobium, glass. So for everything that you put up into space, at that time it was costing you about $10,000 to $20,000 a kilogram. Now it's a lot less, but it's still expensive enough to say, what if we were to, let me go back to maybe a fundamental thing. Unless something catastrophic, more catastrophic than COVID happens, humanity will explore and develop space forever. And the reason that we'll do that is there's a lot of resources there. But getting those resources and refining them into other practical products is challenging. And we've got a bunch of space qualified materials in orbit right now constituting a nuisance. What if we can recover them and turn them and recycle them into other spacecraft, into life support components, into new habitat support materials on the moon and Mars? That means we would need to move the debris that's out there to a safe location where people could then go and visit and pick up something that they would then go and recycle. Now, just to show you that the difference between a bug and a feature is entirely the way you're looking at it, on this slide, you can see with the 2021 orbital debris status. Now, can you see my cursor? Is my cursor showing up to you?
Yes.
Okay, good. So you see right here in 2007, that's when the Russian Cosmos satellite hit the Iridium satellite. And see all the debris that was generated from that one event? It's still there. So you have one of these fragmentation events, it doesn't go away. Maybe some of it fell back into the Earth's atmosphere and burned up, but a lot of it is just still there. Not only that, if you take a look at the spacecraft line is just increasing. We're seeing it with Starlink, OneWeb, some of the other satellites. So all of this is going to, and launches are going up. The number of people that want to go to space is increasing. The number of payloads we want to increase in space, send up to space is increasing, which means there's going to be a lot more spacecraft flying through a lot more debris. And this is not a good thing. So one way or another, we need to deal with it. And so what we looked at is there a way to make it in space rather than taking it in space? And if we can repurpose these, we would be able to enable new and more missions. We'd be able to recycle spacecraft and send them to new destinations. It would allow us to provide new life support and other components for expanding space habitats and expanding space capabilities and so forth, and extend the operating lifetime of the existing ones by repurposing and fixing. So we put it all together, that we looked at how to recover a whole bunch of things. So one of them on the left, we looked at how to fuel. Now, one of the groups that I've worked with, that Bruce and Dan have worked with over the years, are groups that are looking at in-space mining. And one of the reasons they're interested in mining is to produce propellant on the moon and Mars to support vehicles go visiting. And leaving those planetary surfaces to return to Earth. And we're jettisoning and destroying anywhere between 1.5 to 5 metric tons of unused fuel. And most spacecraft that go up have 1.5 tons of unused payload carrying capacity in some cases. So there's a lot of, and that the rockets that right now we allow to burn up in the atmosphere actually represent about 20 metric tons of repurposable metal or refuelable components. So these can be used as tugs, as space tankers, as in some cases people have talked about recycling some of the event stages into habitats. And all of those would be possible. And then we can also use the unused capacity on the launch vehicles to deliver some of the equipment and materials, spacecraft, propulsion components, and so forth that you would need in order to move some of this upper debris into safer locations. And then I just wanted to end this with, I put, let me stop sharing. I put a link in the chat. I'm going to give it a try and hope for the best and see if you can see it again. And if you can, it's a short one, but it's an interesting one, I think. Going to go to the application window, and there it is. Share that. All right, you should see something that says learn more, and there's like a video. Can you see that?
Yes.
Okay. All right, let us run it. And what this is the growth of orbital debris between 1960 and 2020. It's a short film. And you can see that these are materials that are more. Can you see it?
No.
Oh, okay. All right, so maybe what happened is when I went full screen, we lost it. Let's try it again. Can you see it now?
No.
Oh. All right, let me try one more thing and then I'll stop doing it. So you're saying that you do see the page, but you don't see the video,
No,
is that?
we don't see the page anymore. We just see your name.
Oh, all
I
right,
don't
let me
think you're
try that
sharing your
one.
screen. Yeah, you might have stopped.
There we go. Let me try that now. Can you see it now?
Yeah.
All right. Now, if I go full screen, do we lose it?
Yeah.
Yep. All right, that was the problem. All right, we'll do it small screen. It's easy to see. So try that one more time. And you see it now, correct?
Yeah.
All right, let's just roll it. So this shows the buildup of orbital debris between 1960 and the present. Yeah, and we're tracking our object greater than 10 centimeters. Let me just say, if 9 centimeters hits you, it's gonna be a bad day.
If 1 centimeter hits you, it's going to be a bad day.
Yeah.
I mean, one of the things that they've had damage in the space station, and one of the things they found out was one of the things that damaged one of the windows was actually a fleck of paint.
Yeah, because it's going so fast.
It didn't break the window, but it certainly put a pit in it. So as you can see, our neighborhood has gotten kind of trashy.
Now, you can look at that and say, wow, that is a lot of junk. Or you could look at that and say, look at all that refined metal. Wonder what we can do with that. So I think the challenge to all of you, by the way, in the link that I sent in for that video, it actually takes you to NASA's Orbital Debris site. There will be data there. There are models there. There's other information that you can use if you decide you want to look at this. What I'm going to do is maybe put my colleague Bruce on the spot and say, if you were going to send the orbital debris somewhere, where would you send it?
So I guess the thing that's been the most attractive to me was that you'd want to consolidate it. So a lot of this stuff is tanks and things like that. So one of our colleagues had this idea of what he called a nibbler. So one of the things would be that would just go out and kind of chew the stuff up. Either that or you could condense sunlight and melt it. But what you'd want to do is to put this into a form that it was more useful. So I'm going to talk about that on the next slide. So if you can stop sharing, Lynn, then I will put up the last slide here, which is kind of some of the challenges that we might want to undertake here. So let me go see where the heck that is. Oops. Can you see it? Can you see that it says orbital debris challenges, or am I?
Nope, we can see it.
Okay. So, so I just was kind of thinking about, and again, I don't want to constrain your creativity here, but these were just some of the things that I thought you might want to look at as possible challenges here. So one of the challenges here is that the Air Force right now tracks, as they said, 22,000 of these objects, and they have a weird word for it. When there's a collision or a potential for a collision, they call that a conjunction. So that's the weird word that they use. So, and again, if you have one of these conjunction collisions, you're going to have a really bad day. So if you have a satellite and somebody calls you up on the phone and says, you've got a potential of like a 5% probability that you're going to be impacted, tomorrow or something like that, then you got to make up your mind what you're going to do. So one of so there's a number of challenges. So the Air Force really doesn't want to do this anymore. So the legislation was passed recently in the United States that transfers responsibility for this from the Air Force to the Department of Commerce. So that's going to take a while, but this is a thorny problem because what you don't want is a lot of false warnings. There's a story of the little boy who cried wolf. So that's one of the problems that we get into is a lot of where as Lynn's graphic showed, 20 years ago, you might get one of these a month. Of these warnings of a conjunction. And some of the really crowded orbits right now, you might get several of these a day. So it makes operating your space vehicle very thorny. So that's one of those things is, could we find a better way to do this? And then once you decide that you do want to move, where do I move to? So I want to make sure that if I'm moving, I don't want to jump out of the way of getting hit by a car or a bicycle and then hit by a bus. So you want to make sure you're really going to a place that's safe. And while you're trying to do with this with all the moving pieces, that's quite a challenging thing in itself. Then there's the deorbiting of the orbital debris. There's several companies that are working on this right now, but there's a number of challenges there. As I said, because of the orbital mechanics, how do I get to the thing that I want to deorbit? And then how am I going to latch onto it or interact with it in some way to reduce the velocity so that I can deorbit it? And this could include lasers and some other methods that don't necessarily. You saw that one picture of a net going up and grabbing things. There's all kinds of different ideas, but what you'd really love to have is going to the Star Trek tractor beam. That's what you'd really like to have, but nobody's been able to come up with how to do that. And then Lynn just talked about the 3D, the recycling and the potential that would open on-orbit manufacturing or repurposing things like taking a spent rocket stage and repurposing it for habitation or some things like that. So, but the other challenge is while you're doing all these neat things in space, you want to make sure you're doing that in such a way that you're not creating more debris. So if you're going to go repurpose and you're going to be getting into things, how do you do that without creating more debris? So that's kind of the challenge there. And then there's always the show the money problem. Is who's going to pay for this? Where does the money come from? How do you come up with the cash to actually do that, to launch things into space and to deorbit things? So there's an incentive system. One of the things, the challenges here, and this goes to the last one, which is the legal and regulatory aspects of this that I talked about a little bit before, is that you can't interact with something that you don't own or that your country doesn't own. So you can't go to another country's things, even if you think it's kind of a threat, and deal with it without having a bunch of legal hassles there. There's a concept that I would recommend that you look at. It's called the commons, or sometimes referred to as the tragedy of the commons, where you have a common resource and you would like to assume that everybody is going to be friendly in the way that they expect that. But like in California, one of the things that we have is we have problems with water. And so a lot of people pump water out of the underground aquifer. So that's what you could call a common. It's a big thing that goes, across large parts of the state, but it's a finite resource. And so if some people are trying to conserve water, but other people are pumping water like crazy, then the question is how do you control that common asset? Another one is fishing in international waters. where how do you make sure that people are being sustainable and you're not just going to destroy all the fish in the ocean. So these are some really thorny terrestrial problems that we have, but the same kinds of problems exist up in space. How do we handle this common thing, and how do we come up with a global understanding of how we want to deal with this? Now, there are some measures underway in the UN and other places, but this is still still kind of a thorny issue. And then the last thing I'll say before we take questions is one of the neatest things I thought was somebody came up with the idea, and I don't know who to attribute this to, was offering a bounty on these things based on their potential for doing harm. So either you could out a bounty that say that we want to put a bounty out on these pieces of debris to deorbit them, or if you were looking to repurpose them, what you could do is, and to country that had a company that had a dead asset, and you could say, hey, I'll pay you this much if you give that to me, and I can repurpose it on orbit and recycle it. So there's a number of different things that you might think there. So anyway, this was just my thoughts. I don't know, Lynn, you might have some thoughts on some challenges, but this is what first came to mind for me.
So actually, I think that's really great. I think these are good challenges. I do think that there's one piece that you need for recycling, and that's the ability to move the orbital debris from where it is to some other location. Whereas in the deorbiting, you need to figure out how to get whatever you're going to use to deorbit a satellite to that satellite and then activate it for entry into the atmosphere. So in either case, you've got to get to a piece of orbital debris, attach something to it, or probably interact with it in some way and move it to someplace else. And so anything that can be done that's really efficient in doing it. Like one of the things that I was thinking of, that would be a great experiment to do if we could figure out how to do it with using US assets that are up there, is moving a US asset and then recycling it into a craft that goes and gets other orbital debris assets, and on doing this for a while, until you have a collection of materials in a location, and you have the capability going back and forth and harvesting it. You have to be able, once you deliver it to that other location, if you want to repurpose it, you also need to be able to get to it, grapple it, bring it back. And this is where you have things like barcodes, so that you can find the piece that you're looking for. So, but yeah, I think that these are great challenges.
So one thing that I would just, as just my personal opinion here, having dealt with this for many years, the guy in the video talked about using laser beams or ion beams to do that, to re-enter things. That would probably freak a lot of people out, because they would look at that as a weapon. Because if you can zap a dead satellite, you could probably zap a live satellite, and then that might be a little contentious. So that would be another one of the things you have to look at, is if you can use this for beneficial things, you could use this for mischief as well. So just another thing. So we've got a few minutes left, so why don't I stop sharing and we can open this up for questions. So, do we have any questions?
I love the trashy travelers. Somebody put in.
Yes, trashy space travelers, yeah. And some of that is just kind of inevitable, that you can't keep track of everything that you use there, but you just want to be kind of a good citizen. It's like if you go camping, there's a rule in camping that if you bring it in, you take it out. So you want to just kind of have that kind of mindset. Here's the question. How do you cope with the space debris that re-entered the Earth's atmosphere and crashed? Does NASA detect it. Usually you try to put that down in the ocean. The good news is the world is kind of a big place and most of it is covered in ocean. So in all likelihood, when something re-enters, but what with like when SpaceX launches a rocket and they are re-entering the upper stage, they target that for a place in the South Pacific, and then they warn people that that's going to be happening so that people are on the lookout. But that's still a pretty remote possibility. I remember when Skylab came down in the late 70s, and they didn't know where it was going to come down, and so that was a big question. And then the same thing when the Mir space station came down, that was a big question where it was going to come down and was it going to hit anybody or hurt anybody. Fortunately, there have been very few cases of where orbital debris has caused any damage at all, but it's certainly a possibility, and something you need to take into account. What will be the role of space tech startups in the near future? Will it have a positive or negative impact on space? Oh, that's a really good question.
It is a really good question.
It depends. I would say it depends on, is the glass half empty or half full? If we go into space and everybody kind of thinks that this is the wild, wild west, and again, does, irresponsible things, then it could be bad. But I think right now there is a legal regime to launch something into space. You need a license to do that. And the launching country, whoever launches the stuff into space, is responsible for what they launch. Again, this is the Outer Space Treaty. So to get that launch license, you kind of have to tell right now that is in the United States, that's controlled by the Federal Aviation Administration. They have a special division called AST. I don't know what AST stands for, but the government loves acronyms. But that's the space part of it, and they do all the licensing for ULA and SpaceX and all the other one, Northrop Grumman, and all the people that launch stuff into space. You have to get a launch license. So part of the launch license, they will ask you, what are you going to do? But they control the launch and the reentry, but they don't control what you do on orbit. So one of the holes in the whole regulatory structure right now is who controls, the stuff that the United States launches while they're up in space. So that's really kind of unknown right now. So there are some challenges and some unknowns here. I'm hopeful that this will be a positive thing, but I can tell you that for sure.
So I'd like to weigh in. I think it's positive. I mean, I think that there needs to be a regulatory environment that ensures that space is available in the common heritage of humanity. So I think that we need to take care with that. But in terms of what the startup and the tech companies are doing, it's pretty terrific. So should be able using this. So here's one. The U.S. Geological Survey puts out a list every year of the minerals that are critical for the United States to use for industry, for defense. And a lot of them are from, these are what we import from other countries for the most part, and we import them from countries that we don't always have a good relationship with. I don't want any kids going to war over rocks. And one of the things that we can do, there's a lot of the minerals that are on that critical minerals list all over the solar system and on the moon. They're in abundance. And so over time, I believe that what the tech companies are doing by making smarter spacecraft, more capable spacecraft, more spacecraft that are used more frequently, are more effective, more cost effective, all of that plays into a better world than if didn't do it. The governments all have a role. The gonzo creativity we see out throughout society, throughout America, of inventors and innovators and people with just good ideas on how to get things done is much larger than we're tapping into. So as high-tech companies like SpaceX have caused the launch costs to go down, it means that many more minds, or the products of your hands than mine, can go to space to solve problems and to to craft better futures for humanity.
So we got a question along those lines. Is the question is, how far do you think we are from having commercial companies attempting to commercialize space, i.e. mining, tourism, etc.? Are there any companies operating in this space right now that you know of? And I would say yes, SpaceX.
Lots.
They've got the commercial crew program working now, and they have a contract at the end of this year to fly 4 private astronauts to low Earth orbit, and this is all done privately. So NASA doesn't have any role in this whatsoever. This is a purely commercial thing, and this is the first time that's ever, as far as I know, that's ever happened.
And then Axiom, NanoRack, Space Tango, lots of other folks, Off-World, you know, a lot of different groups, not just about launch vehicle, but about what you can do with the space environment. And that's a huge number, and they're contributing very importantly. So there are many, and in fact, all of those are potential job opportunities for you all. In fact, what we're going to turn for. Yeah. One thing
about this, and I think that you will see, you know, mining, you know, people on the moon and resource extraction, mining and processing of lunar materials in this decade. Again, I tend to be optimistic, but I really think that that's a reasonable probability that you'll see them. So I think you guys are in exactly, if you're interested in this topic, you're in exactly the right place at exactly the right time to help make these things happen, and I'm really happy for you and frankly envious. Any more questions? We're about out of time here. We got about 5.
Oh, we got a lot. So there's one. There's a lot of good questions here. So it says, why does NASA say everything is a lot into the future? And that's a really good question, because we actually think that things can be done faster. Now, it requires putting more funds into it for the most part. So in some cases, you're dollar limited, but in some cases, it's going to require a new way of developing space that involves more of the commercial companies than we have in the past, in a far more collaborative and partnership type of relationship. And I think that's very healthy.
And then somebody asked a question about when you liquidate, you know, the base assets and everything, who's responsible?
That's a good question.
So the question here is if you're responsible for it. The challenge here with the space station is it was launched by a whole bunch of people. The Japanese launched things, the Europeans launched things, the Russians launched things. So it's kind of this international consortium, a collaboration. And so one of the reasons why I don't think that the space station is going to come down anytime soon is that I don't think anybody really knows how to untangle that Gordian knot.
But I know who's responsible for it. It's Mary Beth Anine.
Yeah, and I don't envy her job of trying to figure out how that's going to work. But
so is that about 1 million pounds of spacecraft? I think it is
420,000 pounds of spacecraft. Yeah,
that's a lot of spacecraft.
That's a lot of spacecraft. Now, and again, with you know, Starlink and what Elon's doing with Kuiper, which is what Bezos is doing with OneWeb, you're going to have all of these new satellites in there. So this challenge, however great it is right now, is only going to get worse, you know, more challenging as time goes by. So this idea of, you know, having a tow truck in space that you tow things out of the way and deorbit them, I think that's going to be one of the essential pieces of infrastructure you're going to need here. And then some traffic cops, some international ways of kind of directing traffic in space. We kind of have that now, but it's kind of clumsy and cumbersome how that operates, and it's going to need to be more integrated and more timely, because you find out you're going to have a real problem in 10 minutes, you can't write somebody a letter. So how are we going to deal with that? Now, the other side of that coin is now we've got AI and machine learning and quantum computing and all these kinds of tools in our tool belt that we never had before. So how can those be applied to helping us solve some of these future problems? So maybe that's something that you can discuss during your hack here.
So Bruce, just one thing. The space is 930,000 pounds. It's about 450,000 kilos. But one of the things you may want to look at for orbital debris is what would you do with the space station?
Yeah.
How would you recycle the station? It's approaching end of life this decade. This is not a long-term thing. This is soon.
Yep, that would be a good one too. So anyway, I will be available online throughout the day. I will try to check in on the website, and if you got any questions, I will be happy to try to answer them to the best of my ability. And we wish you the very best of luck.
Thank you so much for coming. That was really interesting. And yeah, I believe you're also a mentor on our Discord, so you ping him as much as you want. Thank you.
Thanks.
Thank you. Take care, guys.
Bye-bye.
Thank you all.
Bye-bye.
Bye.
Bye.